Hello, everybody. Thanks for coming. So, in case you're thinking you're in the wrong room, this is what we're talking about today. So it's going native with Apache Cassandra. So, about me, my name's Johnny. I'm a solutions architect at a company called DataStax. If you want to stalk me, there's all my information. DataStax is a company that was set up by Jonathan Ellis and Matt File a few years ago to really provide a kind of a commercial support, enhance the product around Cassandra, and it's been a pretty interesting couple of years. We have quite a few customers now. We contribute roughly 80% of the code into the Apache project, and we're headquartered out of San Francisco, and Europe one's in Stockley Park, which is definitely not as nice as San Francisco. Yeah, I wish, yeah. But, and oblivious, we are hiring, so if anybody's very, very keen, please have a look at our site. So, what do I mean by going native with Cassandra? So, traditionally, when Cassandra was first starting, really the main way of integrating with it and using it was through Thrift. And there was a bunch of Thrift clients around there, Hector, Astynax, etc. And what happened with Cassandra 1.2, really CQL and the native protocol got to a point where I think it was pretty good, and it's becoming pretty much the de facto way of developing against Cassandra. But why did we do this? Why did we move from one to the other? Not that there's anything wrong with Thrift. If you're still using Thrift and you're comfortable with Thrift, do use it. But really, what we found from the community and the developers was, first thing, it was a lot harder to get up and running with Thrift, get familiar with how it works. And it really wasn't, the way the Thrift protocol works wasn't really a good best practice for scaling up in a very large distributed database, distributed system. And it also enables us to give a slightly more integrated experience into Cassandra in terms of the drivers and the tooling around that. And from a kind of a product point of view, from adding new stuff to Cassandra, because you don't, the different Thrift clients, keeping them compatible with what was happening in Cassandra and maintaining that going forward, it was getting hard. So we introduced the CQL and the native protocol. I should point out as well, Astynax, Netflix are introducing the native protocol into their Astynax driver as well. So because they want to make sure that people know this. So just to start, what I'll do is I'll give you a quick run through CQL. How familiar is everybody here with Cassandra? Have you used it before? Great. So hopefully you know what Cassandra is. It's a distributed database. So CQL is a Cassandra Query Language. It was really intended to make it much simpler for developers and people to use to query and model. And you probably already know it if you've come from an SQL background. And, there's a simple statement, select star from users. This is the same, whichever way you're doing it. And it has the usual statements in there, creating, dropping, altering, user permissions, all that kind of stuff. So it should give you a very comfortable way of working with Cassandra. So example here, so this is creating a key space. So creating a key space in CQL, what you're doing there is you're saying, creating my key space Johnny, I'm giving it a network topology strategy, and I'm saying replicate my data between two different data centers. Simple as that. I'm going to rush through this because there is a lot to cover. From the basics point of view, what you have here is a statement there to create a table. Should be quite easy to understand what's going on there. There's a select query there, very, very simple, and an insert statement. Only thing to really point out here is it's worth understanding what that primary key definition means. There is the concept of obviously a partition key and the clustering columns in there. So the blue bit is the partition key, and the orangey bits are your clustering columns. Now, the partition key is, if you know Cassandra, you will know this. It really is the value that's used to give affinity to certain nodes and replicas in your cluster. And then the clustering columns are really about ordering your data on that node. So it's Very straightforward stuff. And it's also worth pointing out that you can have more than one clustering column in there, and you can have composite partition keys as well. So you could have T name and player name as your partition key. So you can get quite clever with it. Also worth pointing out, there are some data types that you might not be aware of. One of the new ones that came in recently was collections as a data type. So what you get with collections is you get set, lists, and maps. And if you wanted to create a table using those in those columns, it's fairly simple to set up. You've got a set example, and a list example, and a map example in there. There are some performance considerations around using collections. So just be conscious of what you're doing. Sometimes it is still more efficient to denormalize your data than use a collection column. Also, do favor sets over lists. They are more performant. And I'd also tell you guys to look out for Cassandra 2.1, where they are still in beta, so not necessarily, but they are putting a lot of indexing in around collections as well. So this is quite a nice way of modeling stuff in Cassandra. Other thing you can do is you can do query tracing. So you can turn this on and off if you're using the command line prompt. So you turn this off in your session, and when you execute a query, you get back a bunch of diagnostic information on what it did. So you know which nodes it went to, the time it took, etc. And this is your friend. Yeah, query tracing is going to help you a lot. If your query is running slow, this will tell you why it's running slow. And I'd always advise, and even if you're just wanting to learn, it's a very, very helpful tool. So you can actually, it goes through all the steps that query took, what nodes it went out to, how long it took to come back, etc. So when you're looking at tuning your queries, optimizing it, debugging, this will help you a lot. There's also a lot more that you can do with CQL. We have lightweight transactions. Lightweight transactions are, on a per operation basis, a way of essentially doing a compare and set on a statement. So you're saying, insert this data if this condition matches it. You've got counters. So counters, as is probably fairly obvious what counters do, it gives you the ability to do incrementing values in columns. We also have time to live. So on a per insert, you can set a TTL for that data. Once that TTL is expired, that data will no longer be returned. We also have batch statements. So batch statements are a way of batching up a multitude of statements. They are atomic in what they do. And I'd also suggest looking quite closely at what's coming out in 2.06 and 2.1, also around using lightweight transactions within batch statements as well. So this is a very quick overview of CQL, but really the point to get across is it's giving you a very familiar tool to connect up, query, model your data. And there's a lot of information out there, which I'd suggest you looking at. There's a bunch of talks out there that would help. But I could talk about this for an hour rather than everything else. So probably what's quite interesting is how we've got the CQL, which gives you the query language for connecting up, and then we've built a whole different way of connecting into Cassandra. Yeah. So part of when you're using CQL is you can use the native protocol as opposed to the traditional Thrift RPC protocol for connecting into Cassandra. So what this is doing, it is essentially we support request pipelining. So your client connects up to your Cassandra cluster. It opens up a certain number of persistent connections in there. And what we're doing there is we're sending a multitude of requests concurrently down the same connection and getting them back on potentially the same connection as well. And this is a two-way conversation. So we are getting not just request reply, we're also getting push events back from Cassandra. Now, the reason, so just to be quite clear on the type of notifications you get back from Cassandra, previously, if you wanted to have awareness of the topology of what's going on, your client would be polling your Cassandra cluster, going out, getting request reply. what we do now is when you're using the native protocol, any changes, any kind of technical events that happen on your cluster, your clients are now aware of them. And this type of data informs the client driver as to what it needs to be doing around load balancing, etc. Now, the type of events you get back are topology changes, a node has gone down, a node has come up, changes to your schema. These are the type of things that get notified to the client driver, not data mutations. So you don't have, if this row changes, something tells me about it. It's just the technical stuff for the driver. But it's quite a handy thing to have. And then really the driver itself is built from the ground up to be, it's a completely asynchronous architecture. What we've done is, in case of the Java stuff, we've used Netty extensively to give you non-blocking I/O around there. And it's really, really handy because the way, and I'll get into it when we start looking at some code examples, given that we have this now very asynchronous way of so we're multiplexing requests over the sockets, we're not blocking any threads. It really does mean your ability to scale, whether it's internally within your client and also the amount of resources it takes to work with Cassandra is quite different and it's quite changed. So that's very much in a nutshell. There's a lot more to this. What I'm going to do now is just really talk about the, more from a development point of view, talk about the drivers, how they work, things like that. So, the native drivers. So at DataStax, we've produced a bunch of the ones there in bold. We have these DataStax native drivers, and we have written them in Java, C#, Python. You've got C++ in beta. Not quite sure when that's going to go. We've got the ODBC as well, and there's also a bunch of community drivers built in addition to this, in Clojure, Erlang, Node, Ruby, etc. And there's lots and lots of different there. You should depends on the language you're using, but the tools are there for you to use, for you to connect up with. So, what I'll do now is focusing on the Java driver. I'll take you through some ways of using it and cool things there, and then at the end we can have some questions. So, first thing, from a client point of view, when you decide to connect up to Cassandra, the first thing you do is you'll build a cluster. And what's quite important there, first thing you'll observe is it's using the builder pattern. It's all very fluid interface for building this stuff up. First thing you have there is you've got these contact points. So the contact points are really telling the client, discover the cluster. Yeah. So it says, connect up, tell me everything about this Cassandra cluster I need to use. Very much in the same way your listeners work when you're configuring Cassandra. We're not saying connect to these nodes and you're querying. It's just, I need to go and discover my cluster. I need to know the topology of my cluster, the partitioning, everything you want to know about your cluster. And then you build that. You then create a session of that cluster. And you've optionally got the ability to create a session on a key space or just up to the cluster in itself. Obviously, if you don't specify the key space, you can then qualify that exactly the way you would do it SQL with your SQL statements. And then, once you've got this session back, you can then execute queries against your data. And here's an example there, just doing a fairly straightforward insert into it. And that is not my password for anything. So yeah, there you go. So it's also worth noting that your cluster objects and your session objects, these are long-lived objects in your application. These aren't things you would be instantiating frequently. So reuse them, keep them alive for a long time. But in the same way, there are shutdown methods like you would on traditional JDBC stuff. So tidy up when you are done. Don't just leave it hanging around. But really, they are intended to be long-lived and to be reused within your application. OK. So next example here is reading from a table. So you call session.execute with a bit of SQL there, select star from users, and you get back a result set. And I don't think there's anything really to explain about this one. You get back some rows, and you iterate through them, and you do stuff with them. Very simple, very, very straightforward. However, there are cooler things you can do with this. And this comes down to the way we've adopted this asynchronous architecture. So you can do, you can basically, see that execute async method up there? This gives you the ability to asynchronously make, as the name implies, asynchronously execute queries against there. So this is really, really handy for a lot, and I'll show you some examples that did it. But because what this does is you get back a bunch of features, and these features are implementing Guava's listenable interface, which also, as a consequence, means all of the very cool things you can do with Guava future methods, you can now do with your queries into there. And this is very, very nice stuff. And the reason it's quite nice is because it lends itself to doing to large scale, and you're not blocking your client here. You can essentially execute your method. If this is a very horrible, big, long query or a big bunch of inserts, you say, come back, tell me when you're done, and do that. And you can, to do that, what you can do is you can register callbacks. So, example here, what we've done is, imagine this select star from users probably would be a very horrible query, and we give you back a large amount of data. And what I can do there is, from a client point of view, I can say, when you come back, execute add a listener there, runnable, and call that run method, and do something there. And this can be anything you want to do. Example here is really just, when you get back the row, iterate through it and do your stuff. But this is a very, very, very handy thing to be able to do, because it also enables you to parallelize your calls. So, very, very simple example, but what this is trying to show to you here is, similar query, I've created a bunch of, I'll call it the session execute async. That gives me back an object that adds to my futures array list, and then I can go and just chuck in as many queries as I want in there, go away, and come back later on when they're returned, and do something with those results. And the reason this is quite handy is it lets you really optimize how you're doing. And if you are having to do lots and lots of big queries, so you're getting back, you want to insert lots of data, or I want to do lots and lots of selects, rather than getting back one big select, break it down into smaller queries, because this gives you it gives you a lot of advantages. I mean, first of all, it's very easy to do it with the execute async and with the features on there. But the problem with doing large queries in this is that it can result in, for instance, your coordinator node doing a lot of work, and that introduces a certain amount of hotspot on that node, which will then have an effect on general throughput and stuff there. So breaking things down to smaller queries is often better than having just one big query. It also, it will, if you have, if you're using, which I'll talk about later, if you are starting to use latency awareness for your load balancing, this can often skew this, because you're giving a very expensive operation, so your 99th percentile is now thinking, oh, this node is slower than actually it's just doing a lot of work. So it can skew that. And the other big advantage of breaking things down to smaller queries is, if that query fails, it's fine, I can retry it. It's not an expensive operation. If this is a massive select star from users, then, oh my God, something's failed halfway through, I now need to do this again. So obviously there's going to be some use cases in your apps where this might not be appropriate, but it's your friend to do this. And because you can use this in conjunction with registering listeners and callbacks, you can bring it all together as you need it. So, other thing you've got with the native protocol is you've got prepared statements. And this is just like prepared statements in your traditional JDBC world. So these statements get compiled once. They're intended for multiple execution, and it's really, really straightforward to use it. If anybody's ever written any Java code connecting to a database, you will understand exactly what's happening here. There are some considerations around prepared statements. I mean, don't prepare a statement unless you are going to be reusing it. I think that's glaringly obvious. But yeah, these are your friend. This is something you will predominantly use as prepared statements. And there's more ways of binding your variables into there, and you can do it by index, you can do it by name. I think there's also, you can define variables now as well and substitute stuff in. So it's fairly easy to use. And then the other thing we have is we've introduced a query builder, and this lets you, if you don't want to write CQL, or you have maybe it's you're dynamically building up queries in some way, you can use the query builder to essentially programmatically build yourself up. And in this example here, it's exactly like the other one. I'm selecting all from a key space table user where the username equals Johnny. And if that's what you like, if this is how you will help you in how you want to develop, and if you're comfortable with that, this is a really nice way of doing it. It's worth also pointing out consistency level. So I'm assuming everybody here knows about consistency with Cassandra and especially consistency. So whether it's with the previous examples of that, if you want to set your consistency level, you just call set consistency level on that query, and then you pass in whatever you want. Worth pointing out, the default is consistency level of 1. So that's somewhat redundant, but just be aware of that. If you don't set it, it will be using consistency level of 1. And then same way, you build up that query, you call session.execute, you get your results back. So really, if you're going to take away anything from these previous slides, it probably should be the asynchronous nature of how you can use the calls there. I mean, it is really, really cool and very, very efficient for doing so. And it really does lend itself to a lot of use cases now. But I mean, it's all non-blocking I/O. It's very, very nice, and you will see a lot of performance differences. Then, particularly if you start breaking things up, bulk reads, bulk writes. It's a very, very handy way of splitting the workload more evenly around your cluster. So use it and have fun. All right. So what you've also got with the drivers and the native protocol are a bunch of policies, and the policies are for load balancing, for reconnection, for retries. And there are a bunch of pre-written choices, policies for you to use. So first one here we've got is a multi-data center load balancing policy. And what this is saying to your client, it's saying you're now be aware of all the different data centers in my cluster, and obviously it is a round-robin policy within that data center, and all you're doing is you're calling, when you instantiate that cluster, and you've added your contact points, you say use this load balancing policy, instantiate that DC-aware round-robin policy, and pass in the name of your local data center. And what will happen there is if, for whatever reason, when you try to execute something against that local data center, if it's not available or it's potentially not, I mean, it could be available for, maybe it's slow, maybe it's timed out, it will switch over to a remote data center and execute the query against there instead. And that's quite nice. So it gives you a lot of tolerance to failure, to things flapping, to stuff like that. Or if you're hammering that local data center, it's having problems, fine, let's start switching some of my requests over to my other data center. Another one you've got is you've got a token-aware load balancing policy. Now, with a token-aware load balancing policy, what it's doing is, so when your client connects into Cassandra, it chooses a coordinator node. As you all know, Cassandra is entirely masterless. Doesn't matter which node it chooses to, and it's still the case. But what the token-aware policy means is I will connect to one of the nodes that own this partition of data. And what that means is I don't have to go do it like, for instance, a network hop from the coordinator to the other nodes, because my data is already residing on the node I'm connecting to. And that's quite nice. And the reason it's, what makes it even nicer is because the client driver is getting these events pushed to it, when you change you add nodes, you change the partition ranges across your nodes, your client's told about this. It knows. It's always aware of which nodes own what token ranges. And really the way to use this is to, you instantiate it with a child policy as well. You have to instantiate it with a child policy. And example here, this is actually a very, very common way of setting up your cluster is so you instantiate your token aware policy, and then you use, once I'm token aware, also make me DC aware. So I'll connect to my local data center. I will choose a coordinator that has an affinity to that partition of data, and then when I connect to a remote data center, I'll do the same thing. And it's very nice. And then we have, and I probably should say that there is a default policy as well for load balancing, which is just round robining. So if you don't specify with load balancing policy, it will just be round robining across whatever you tell it to connect to. So the next set of policies we have are retry policies. And a retry policy is telling you what should I do when for whatever my request returns a timeout or the node is unavailable or whatever. And just like with the load balancing policy, when you instantiate your cluster, you say, build my cluster with this retry policy, and you specify which one you want in there. And there are a bunch of retry policies to choose from. So you've got, obviously, the default retry policy, which it's quite conservative in what it does. It will just retry. It just doesn't do much. The next one there, which we're using in that example, is the downgrading consistency retry policy. And what this is intended to do, and you should use it with caution. Don't use this unless you genuinely know what you're doing. Because what will happen is the idea here is for example, I've called consistency level of all, and I'm executing my query against Cassandra. For some reason, imagine I'm in a multi-data center deployment. The connectivity to my other data center is unavailable. I can't honor that consistency level because I can't get the ACK back from all my multitudes of data centers. So what do? You can fail the request, say, well, I can't honor all, or I can say, you know what, okay, I'll drop down to a weaker level of consistency. So, for instance, I go from all maybe to say local quorum, and then when the connectivity comes back up, it will retry and do this. But it's a very handy tool in your box. But I'd probably argue if you've gone for all, you have probably a good reason to go for all. So don't use it just thinking by default, I'll just use this downgrading retry policy. Understand what that means for your application. Understand what that means for your data. Don't just use it out of the box. You've got the fall-through retry policy, which basically doesn't do anything. It just lets that just bubbles that up to your business logic, and you decide what to do in that situation. And then you've got the logging retry policy. The logging retry policy, all it's doing is as with the token policy, you nest the child policy within there, and all this is doing is basically logging out when I retry. And to be honest, I can't see why you wouldn't ever have a retry policy and not want to know if you're retrying because something's really going wrong. So use the logging retry policy. Yeah, it will be fun. And there's a link down there to the Java docs on this, which you can. But retry policies are, it's important to really. I'll say it is quite important to understand what you're doing there. You're retrying on failure, so something has gone wrong. Hence, you're doing this. This isn't like I'm load balancing. This isn't saying I'm going to be routing requests where it's efficient. Something has gone wrong, and you're now retrying. So know what's the right thing to do when that happens, and don't just, particularly the downgrading consistency policy. That's that's a choice you've made for a functional reason, for a requirement to choose that level of consistency. So downgrading is not might not necessarily be the right thing to do. We then have a bunch of reconnection policies, and this is, as I said up there, oh, wow, gosh. This is how often we'll attempt to reconnect to a dead node, how often we do this. And it's fairly brutal. There's really two choices there. You've got a constant reconnection policy, which is saying if my node is marked as down, every X number of milliseconds, try again, up to a maximum period of time. And you then got an exponential reconnection policy where, constant delays in a big distributed system is not a nice thing to start hammering your system. So you start small and you exponentially grow the delay between them, because if it's not working after 1 second, is it really going to work after 4 seconds? So well, actually it doesn't add up, but you know what I mean. So it will just gradually exponentially increase that period up to do that. And I'm always, for me, the constant attempts would worry me in a system, because that type of workload is, if a node goes down, it's probably likely that lots of your clients have noticed this or experiencing an issue and are retrying, and they're all going to start hitting like this. So having a bit of variability in those retry attempts is nice. So yeah, I personally usually go for the exponential one. And I'll also point out, all of these policies, you can write your own. It's quite extensible. This is all up on our GitHub, github.com/DataStax. Very extensible. People do write their own policies. For instance, maybe a time-based one. At midnight, don't use this data center, use this one. Stuff like that. There's lots and lots of ways that you can extend this for whatever your use cases and needs are. Another thing, and the reason this is in there is because this is probably one of the most painful points with early versions of Cassandra. So what you've got, and this you think, well, surely this isn't anything fancy, but in comparison to what we had before, paging was in there. It was quite. This is very, very nice. So so historically, getting large data sets out of Cassandra into your client is a problem, because Cassandra would load that result set into memory, and then you'd drop that result set over to your client. So you'd get these, out of memory exceptions a lot. You'd have problems. So what we have now got is the ability to stream that data across in there. So you can basically be iterating through very large result sets in a very, very efficient, memory efficient way. And you no longer have to batch your selects and get them back like that, which is horrible code and horrible to do. You just do your select star or whatever, and you just iterate through your data. Example here is just showing you how that works. But the one thing that's quite cool about this is the concept of state as you're paging your data. So if you think about it, if in that example there, that client's querying that node there, it gets back the first page of the data. Well, what happens if that node goes down? Yeah. Well, do I have to start again from another node? You don't. What you actually have is essentially a cookie, if you will, that tells you what point you're through there. So if that node goes down, the next page request can simply go to another node in your cluster without having to start again, anything like that. So it is tolerant to failure. And I from a personal point of view, this is, for me, one of the nicest things. Well, there's loads of nice things, but this is a very nice thing, because I hated, it was very ugly to get large result sets back. So this is your friend. You won't even notice it. Other thing we've discussed, and I showed you the example before, was tracing. So yes, in exactly the same way from the CQL command line, you can trace and get your results back. You can also do this within the driver as well. And all you simply do is, regardless of using a query builder or just your own statements, you just essentially call enable tracing on there. And after you execute that query, you get back an execution info object, and from there you can get a query trace object. And this gives you a lot of, this gives you all the diagnostic information that you would be getting had you gone through the command line to do this as well. So you can get, you know what nodes you've attempted, you know the latency if you've the coordinator has gone out to the other nodes to find it. You get a lot of diagnostic information in there. But rather crucially, this is something you're doing programmatically. Yeah? So you're not doing this on a global level. You're not going in and saying, okay, now enable tracing on all my queries. You're doing it on a per statement basis. So that can be a challenge because, well, how do I actually, something's gone wrong, I need to enable tracing. So think carefully about that. And the other thing to also think carefully with tracing is there is a performance cost to enable tracing. I mean, it is persisting data into Cassandra. It is consuming resources. So use it when you need to diagnose stuff. Don't run it in production. Obviously, don't release code with enable tracing on because you're going to just be hammering everything in this. I've seen people do some randomness, turning it on. So just to give them a certain amount of, every 5% of calls, enable tracing. You can do smart things like that if you just want to build up a kind of an audit history of what's going on and doing that. But don't leave it on all the time. Now, the tools you have around the CQL native protocol, you've obviously there's a command line utility, CQLSH, that will let you connect up and do what you like. But we've also built Dev Center. This is completely free. Go download it, have a play with it. And you get all the kind of things you'd want from a tool. You get all the syntax highlighting, auto-completion, pretty colors, connecting up to clusters, managing all that stuff. It's using the native drivers as well. And this is pretty new. We launched this back, what was it, around September, I think, last year. So it's in version 1 at the moment. And yeah, we're very keen for people to try it out, tell us what they think, anything you don't like, anything you'd like to see changed, or any extra things you want to see in there. So finally, there is a bunch of links here that will help you a lot. So the first one there is obviously datastax.com. That's going to where I'd say go to for all your Cassandra stuff. Second link up there is a bunch of stuff there to help you if you've not used Cassandra before, downloading VMs, get yourself up and running on there. We also have quite a comprehensive amount of training, both online training, completely free. Just go off and start using it, learn about it. It is pretty geared up to the native driver and Java and CQL, so it's quite good to do this. From our downloads page, you'll be able to download. First of all, you can download DataStax Enterprise completely for free. It's free for development and testing purposes, and there's a lot of extra stuff on there that you would probably like to use. Our documentation's fairly comprehensive. The developer blog, lots and lots of interesting things there that I'd suggest reading them. There's loads of cool stuff. And the community site for Cassandra is planetcassandra.org. And again, my favorite thing on there is that we have a bunch of use cases and interviews with people, why they've used Cassandra, how they've used Cassandra, stuff like that. And there's tons of webinars over there. So that's me. Thank you. There's a lot to cover. It's quite quick. I could have stood here for a day and talked about this. So it's hard to get it all fitting in. So fifth, yeah. Oh yes. So yes. And I'm here all week. Yeah, great. We got questions coming in already. We're on the 5th floor. Come over, speak to me, speak to any of my colleagues. Any questions you have, anything you want to know, I'm here to help.
And if you don't mind, there's a drawer, if you allow us to sort of scan you. So Jill's out there, she's quite scary, so she'll let you by, honestly. But if you don't mind, we'll do a quick scan on the way out. Thanks.
Cool. So we have some questions. So are you planning to introduce data update notifications? No. And arguably, that's not really the driver's kind of responsibility. If you were asking me how would I do data update notifications, the only thing you've got in your toolbox at the moment is triggers. So triggers are, and I will definitely say this, triggers are experimental. They're there really we put them out with Cassandra. It's there to people, how are people going to use this? How are they going to use it? don't use triggers unless you really know what you're doing and you understand the Cassandra, because you basically write a piece of Java code that can do whatever you like. Yeah. So you're going to be consuming resources in Cassandra, some of that. But triggers would, if you did want to have some form of notification on data mutation, triggers would be the way to do it now, but experimental. And we've also, the Cassandra, we've also said very clearly, when it becomes not experimental, there will be no backwards compatibility. So if you start building a bunch of very complex logic and triggers, just be conscious of what your upgrade path is going to be. So they're there for you to use if you know what you're doing. And we have some very large, very, very large deployments using them. So it's not that it doesn't work, but just be conscious it's experimental and is likely to change as Cassandra moves on. Another one I've got there, using CQL is more easy, but in this way the flexibility decreases. Can Thrift and CQL be mixed? I believe they can. I've not tried it myself, and I have seen a couple of community drivers where they are using CQL over the RPC stuff, but I wouldn't advocate it. I mean, they're made to work. You know, the native protocol in CQL, they really are made to work together. I wouldn't advocate. Personally, I wouldn't advocate it. If it works for you and it's going to do what you want to do, go ahead. But really, CQL native protocol, that's the way to go if you want to go down that route. Another question, is there a Scala client supporting CQL with async API that you would recommend? I'd recommend looking at our client drivers download site on our site, and there is some Scala ones in there. Also, Planet Cassandra, there's some links to some Scala libraries in there. Is there a specific DataStax supported we have built Scala driver? No, but you know, I know it. Well, probably, yeah. I mean, I think the demand is there, and it wouldn't actually be a difficult thing to do because our Java driver, because it's all asynchronous, because it's all non-blocking I/O, it would fit very, very simply into this. Really, all you're doing is, I think, if you built a Scala driver, is just making it a little bit more friendly in how you'd use it. I think you would, ultimately, I think you'd be just delegating out to the Java driver anyway, but you just make it nicer. So, yeah, Scala, and we do have, I do know lots of people using Scala and the native drivers before, but, and you know what, this is all open source, this is all up on GitHub, you know, we'd be quite happy if, you know, you guys want to build a Scala driver, build a Scala driver, you know. Another one there, usually when using Cassandra, you are starting from initial requests and build the key spaces, etc. But adding other info usually implies creating other key spaces. This can result in a performance problem querying multiple key spaces sequentially. What is the power of Cassandra with CQL instead of using relational DBs? That's like a big, big, big question. Let's start with the first one. Usually when you're using Cassandra, you are starting from initial requests and you build the key spaces. So if you're, I'm not quite sure I understand your question there. I mean, if you're talking about data modeling, is that, who asked that question? Yeah, who asked that question? I mean, I'm not quite sure what you're asking, but if you are asking about the approach to modeling data with CQL and Cassandra, I mean, it is a denormalized query-based approach to modeling your data, and which the implication of that is you need to know, well, what am I actually going to, how am I going to be querying to do this? And you're really optimizing for that. You know, there is no secret special sauce that's going to make this any less challenging than it would be. You know, you're going to have issues with if your requirements change or you get new requirements. How do I adopt my model to meet these new requirements? And there's really the question people always ask me, assuming this is the question you were asking, is how do, you know, I've got this massive table with a bunch of data in there that I've optimized around how I'm going to be querying it. You know what? I've now got a new requirement that I need to query it a different way. What do? I create this table, but I've got all this data sitting over here. How do I backfill it to get my table up to date so that my data is now in there, it's queried, it's appropriate to do it? And you know, I'm not going to lie, I don't think that's a particularly easy thing to do. There's no click a button and do it, but there are a bunch of approaches that you've got. You've got very low level. You can start writing SS tables yourself. based on you read in the SS tables from the other table, you read them in, parse them, transform them, write them out to the new SS table format, and then you just stream them back into the table. That's one approach. You would also probably want to start writing in parallel before you do that, so you're just catching up based on when you took the SS table. You've also got, you can brute force it. You can basically write something that's just reading stuff in and writing stuff back out. Not depends on the type of data. And there are some pretty. This is the nice thing with the async stuff. Certainly from a client point of view, it's pretty quick. You can actually pump. I mean, on my laptop, I can pump millions of writes into Cassandra just by purely boom, boom, boom. But that might not suit. And there are a bunch of that whole ecosystem about ETLing and tools around that. That's evolving a lot. We've partnered with Jaspersoft and Pentaho, building these nice kind of ETL load and transform tools, which they are certainly Kettle is CQL compliant in there, and that will let you do this kind of stuff. And other approach you have to do this pre-population is certainly with DataStax Enterprise, which is our kind of Uber product of Cassandra. It gives you, we have an analytics part there, and what that is essentially a HDFS compliant file system sitting on top of your Cassandra column families. And this means you can start writing Hive queries, pig queries, MapReduce jobs. So if you could write something on there to read, transform, and write to my other table, and this would be a batch thing that would just go off and do it, and you'd get through it. So there's a bunch. If that was the question, there's a bunch of approaches to it. So I think I've actually got. I think I finished a bit early actually, which is I was worried about overrunning. So yeah. So thank you very much. If there's no other questions, we'll call it a day. And as I said, I'm down at the booth. Come and speak to me. Ask anything you want to know. And you've got my Twitter and email. Please don't stalk me, but do ask me questions if you want.